So I think our best bet with doing geometry where we need software to do it is to not use the software that's given to us on Pearson because it's very confusing. So what I'm going to do, I'm going to model what I want you guys to do here. I'm going to write down the conditions in this problem on a piece of paper. So we're supposed to use a ruler and a protractor. A protractor is one of those things that help you see how big an angle is. We're going to make a quadrilateral, so I'm going to write that down. So I know it's got to have 4 sides. It has 2 equal sides that meet at a right angle. And of course, or maybe not of course, a right angle is 90 degrees. So we're going to have 2 equal length sides that meet at a corner, and then 2 non-adjacent angles of the same measure. 2 non-adjacent. Okay. So that means that it's going to be 2 angles that aren't next to each other. So just for the sake of argument right now, if I were to draw a quadrilateral, any quadrilateral, all that matters is that it has 4 sides. So let's say that this is the angle that they want to be 90 degrees. So you have this side and this side that are supposed to be equal length, and they're supposed to meet at a 90-degree angle, which is exactly what's happening here. Then it says 2 other angles. Now, how many angles do you have left to work with? Right, you have 3. This one, and this one. Let's call them A, B, and C. So I want you to pick 2 of them that are non-adjacent. So out of A, B, and C, that means which 2 are not next to each other? Well, B is next to both of them, next door neighbors. A is next to B is next to A and C is next to B. So the one that's next to everybody is B. So that means that angle A and angle C are non-adjacent angles. And they're supposed to be of equal measure. So actually, this is one of the right answers to this problem. If this was 90 and this was also 90, because they're supposed to have the same measure, that means the figure that you've drawn is now a square. It has to be a square. There's nothing else it can be, because this side and this side have to be the same length. So where I want us to start drawing these is in this website called GeoGebra, and it's the geometry version of GeoGebra. So if you'll look up here for me in the little address bar, see it says geogebra.org/geometry. Because if you just go to regular old geogebra.org, it's going to take you to a graphing calculator, kind of like Desmos. So here's what I want you to see. So far, when I was practicing, I drew 2 sides from A to B and from B to C. Both of those sides have a measure of 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we're making a 4-sided figure. And so we're supposed to focus on, out of those 4 sides, we're supposed to now, at the 3 angles that are left, focus on the 2 that are not next to each other. So that would be the angle that's going to happen at A and the angle that's going to happen at C. I can zoom in, and zoom out, and all these other super fun things and move it around. So let's see. I'm going to do a segment. No, I'm not. I'm going to do array. Array starts at a point and then just continues on forever in some direction. So I'm going to do array, and I'm going to have it be there, that direction. And I'm going to focus on angle A for just a second, and I want to try to measure it. So let's see if we can measure an angle. So it says select 3 points or 2 lines to measure the angle. So I'm going to select this line and this line, and it tells me that that angle is 113 degrees. So now I'm going to draw another ray. And my next ray is going to start at C, and it's going to go this direction, and I really want this angle to open up 113 degrees, so I'm just going to put it somewhere for now. I'm just going to put it there. I'm going to measure that angle. So I'm going to select this segment and this segment. Oops, that's the exterior. Okay, so we got to pick 3 points instead. How do I undo this? Let's see. Undo, undo, undo. Okay, let's try this again. Let's measure the angle, but let's select the 3 points. And when you're selecting 3 points, the thing that's the most important is that the vertex, that's the corner where the angle actually exists, the vertex has to be the second letter. So I'm looking for angle C, so C has to be the middle letter. So I want to know how big this angle is, so I'm going to select B, C, E, and right now it's telling me that that angle is 92 degrees. I want it to be 113. So you know what I'm going to do? I'm going to try to grab, I'm going to use my move tool, I'm going to grab E and I'm going to move E until it's 113 degrees. It's hard to see, isn't it? There's 115, 14. There is 100. It's as close to 113 degrees as I can get is right there. Okay. So normally if we were doing a construction, I wonder if I can move this guy out of the way. There we go. 100 and, oh, shucks. Yeah, I just did that. Okay, there's 113. If we were doing this construction in class, what I would have you do now is I would have you use an eraser, and I would have you erase these lines out here, and then what we would see is that what we had left could be described as a kite. We can do it again. I'm gonna create a segment. I'm gonna have the segment go from here to here, and then another segment. So this segment is 1, 2, 3 units. So I'm going to have this one go from here to here, also 3 units. It's connecting right at a 90-degree angle, and I can check that. I can check that by grabbing onto my measure section angle, pick my 3 points. Remember, since this is the angle we want, the letter G has to be the middle point. So I'm going to choose this point, and this point. And that is actually 90 degrees. I wonder if I can get rid of the letter there, because that letter is making me crazy. Label. Do not show label. Oh, hey, look at that. So if you grab your move tool and click on the point, whoops, click on the point and then on the letter, you can delete the label. So we can see how many degrees it actually is. Okay, so I'm going to do kind of the same thing I was doing before. And you can keep using segments, or you can use rays, or whatever you want. I'm going to use a segment. I'm going to make my segment go to there. I want to measure this angle. So I choose angle, choose my 3 points, I, F, and then that point. That's 95.1 degrees. So now I'm going to do another segment. I'm going to go from here. I'm going to go through it because I don't know where it should stop. And I'm going to measure that angle. H has got to be the middle, up to J. That's, okay, and let's get rid of that letter. A, turn off label, there, 101. So I'm going to move J until it says 95.1, 95.1. So there we go. So typically, again, I would have us move these points, 95. I would have us move it if this was regular class. You're just working really hard to get these two to be the same. But that, again, is another kite. You could also make that an acute angle. What if I made this angle like 45 degrees, and then I moved this angle to 45 degrees? Okay, that's not a good example because that made it into a triangle. What if we made it like 30 degrees, and then we try to make this one 30 degrees? Let's see. 30 degrees. 30, come on. 30 degrees, and let's move this one to 30 degrees. Whoa, somebody's knocking on the door. Okay. And then if we were in class, I would tell you to erase this, and what we end up getting is this four-sided figure. So I know that the vocab is really rough on some of these, so just do your very best, but I think we're going to start using this website because I think this is the one that's going to help us the most. All right, bye.